Okay, thank you very much for this opportunity. I'd like to talk to you about what I believe is the next frontier of aquaculture or agriculture. It's agriculture of the sea, and I believe we can do sustainable feed, food, and energy using this. You know, agriculture is primarily about capturing solar energy. And as you can see, a lot of the energy of the sun falls in the equatorial region, especially in the areas around India, Indonesia, Malaysia. So it's really about capturing the sun's energy. The sea is very warm. And there are many, there are many seaweeds that can actually grow and use this: Capophycus, Eucuma, Gracilaria. And these are vegetatively propagated, and they can grow and capture the sun's energy and grow rapidly. And as you can see, around the equator, plus or minus 10 degrees, 20 degrees of the equator, all these red spots are areas where these have been successfully cultivated. Tanzania, India, Indonesia especially is a very large cultivator. And all of these are well known, but they're extremely labor intensive. This is the picture from Zanzibar. You can see the women going out into the sea, coming back with boatloads of the seaweed. Actually, the seaweed is grown in these stakes on the ground. There are strings that are attached, and the seaweed is tied on the strings, and it's allowed to grow. And in low tide conditions, it goes on. This is a similar picture from Indonesia, where you can see the people working waist deep in the water. It's really difficult to work in the water, right? I mean, it's hard work, but you can see the seaweed laid out as cabbage patches, people working in the sea. And it's not only is it very difficult to keep walking in the water, there are other very labor-intensive parts of this. For example, these women who are tying the seaweed in little strings, like a rose garland, or this woman in Rameshwaram, or this person who's actually putting out the seaweed in the water, or these people who are bringing out the fully grown seaweed from outside of the water. Extremely labor-intensive, which is why at C6 Energy, we invented what is called the sea tractor, which is like a catamaran boat, which can automate the seaweed cultivation. And the way we do that is we have this tube net, which is stuffed with the seaweed rather than tied with a string. And like a sausage stuffer, it actually stuffs the seaweed, and it's put out in the ocean in long strings. This is typically the kind of scenario you might see: long strings of seaweed in a ladder-like fashion, and the catamaran sea combine can go over it. So what really happens is that this allows farming on a very large scale with reduced labor. What happens then is that the seaweed grows outside of the tube nets, like you can see in this picture. And as the sea combine moves on the ladders, on the seaweed farms, there's a rotary cutter which actually cuts that and strips off the seaweed, puts the tube net back into the water, and it regrows again. You may ask, why do we need to do this? Because it's such a versatile biomass. You can make food additives, biofuels, agri-inputs, organic chemicals, feed additives, if the price is right. And this is really what the potential is. So I know that many people here are interested in aquaculture, so we can make very interesting products from the seaweed. Capophycus alvarezii in a hatchery situation in Vanamai can actually promote vibriosis resistance, stress tolerance, and increases growth. So this is a very interesting product. It doesn't just work for Vanamai. In a monodon situation, seaweed extracts can actually improve the survival in the face of a vibriosis challenge. Compare the blue bars against the gray bars. So we've actually found this actually works very well and can increase the survival. We figured out that there are sulfated galactans, active ingredients in the seaweed. We've done the exercise. They activate many genes in the shrimp hemocyte, actually elevate genes responsible for innate immunity, including those that can fight off microbial infections. So it doesn't just work in a laboratory setting, in a field setting, as you can see from the orange bars. In the Vanamai, yields are actually increased in grow-out ponds, survival increases, and the feed conversion ratio reduces. So these are all products that you can produce for aquaculture. But, you know, it's not just valid for shrimp culture. We've also seen results in tilapia. You can see in a hatchery situation, as well as a grow-out situation, we're seeing really great benefits of using this product. So I've talked to you about a lot about products for aquaculture, but a big product that we can also produce from seaweeds by processing is for agriculture. So sea agriculture can improve land agriculture. And on a variety of crops, rice, maize, sugarcane, you can get yield increases. This product can also improve viral disease resistance in many agricultural crops. Now, that's not the story. By processing the seaweeds in a different way, you can make biodegradable replacements for plastics, sheets, pouches and bags, drinking straws, all that one-time plastic that is today polluting our oceans. And all of that can actually be made from the sea plant material. And in the long term, we've already shown that you can make crude oil from the sea plants. And this bio-crude that you can make using a process called hydrothermal liquefaction is identical to petrocrude. And you can imagine putting that into a refinery to make biologically produced petrol and diesel. How much would that take? Well, a farm the size of Tamil Nadu on the sea, that's less than 100,000 square kilometers, could make enough biomass to replace the entire amount of crude oil produced in India by renewable crude. And ladies and gentlemen, that is why I believe sea agriculture is an ocean of possibilities. Thank you very much.